Many of you may be aware that about 60% of the total outlay for the 6th five-year plan was in the implementation of the new project. Likewise, for the 7th five-year plan, about 63% of the total outlay has been in the new facilities. This amounts to a very large sum of money amounting to 348,000 crores. The government is aware of the loss that the exchequer as well as the nation as a whole is facing because of the slippages of these projects. The implementation of the projects in time is a very, very essential element of the project implementation. It is because of this that about 100 projects costing 100 crores or more are being monitored by the Prime Minister's Secretariat. It is in this light that the seriousness and innovative approach in project management are very essential.
The task of project management is not very easy, especially in our situation with all attendant insufficiencies in the infrastructure, and therefore it calls for greater dynamism in day-to-day implementation of the project. With this in view, a few typical problems in real-life situations pertaining to various disciplines have been compiled, indicating the various alternatives available to the project manager and their possible impact on time and cost. An overall schedule was developed for the ABC project in March 1984. This called for setting up of a large chemical processing plant where the process package was to be supplied by a foreign collaborator. Construction India Limited were retained as consultants by the manufacturer. The process package receipt, detail engineering, procurement, and construction phases were fixed for the targeted mechanical completion date of June 1987. A major revision in the process package was compounded with changes in soil data along with the late receipt of vendor data. Improper bulk material takeoff led to further delay aggravated by scope changes. Delays due to power cuts were interspersed throughout the project implementation period, and the mechanical completion date was deferred till November 1987. The first delay was in receiving the process package. A process package includes the processes or methods for converting the raw material inputs into product outputs, and it also includes the utilities like steam, water, electricity, nitrogen, etc. for carrying out this transformation.
Delay was due to the following reasons. A. The process was under upgradation based on feedback on an installed plant operation using the process. B. There was delay in finalizing the process documents by the licensor. C. The process was under improvements through the R&D results of the licensor. D. There was delay in finalization of process license agreement and clearance by the government.
The alternatives available at that time were A. Issue of requisitions with preliminary data and firming up of the specifications with vendor discussions. B. Obtain itinerary quotation. This, however, had a disadvantage that criteria or quantity could not be clearly stated. C. Wait for the receipt of the process package before initiating actions at the contractor's end. Alternative A, that is, issue requisitions based on preliminary data and firming up of the specifications with vendor discussions, was accepted as best option.
As there was 5 months delay in receipt of the process package for detail engineering, some basic data was collected for preparing the piping material takeoff and equipment specification. This first material takeoff and equipment specification has to be reworked completely after receipt of the process package. This advanced action taken to reduce the time cycle resulted in 5 months of wasted engineering efforts.
Because of the delayed ordering and lack of proper organization on the part of the vendors, the vendor data was made available in parts to the detail engineering contractor from June 1986 to February 1987. The heat exchanger and pump data were available in February 1987 only.
There has been a considerable delay in finalizing the specifications, sizing of the equipment owing to late receipt of the data from the process licensor. This has resulted into the delay of preparing the material requisitions, whereby the project schedule has been adversely affected.
The alternatives available were A. To assume more data on safer side and proceed with design and construction without waiting for electrical and mechanical data to come, which can follow at a later date. B. Tie up attractive payment percentages to the defined milestones of data supply by the vendor. C. Engineering personnel from Construction India Limited could be posted at vendors' works to expedite drawing approval and the vendor data. Alternative A, that is, to assume load data on safer side and carry out design and construction, was accepted as the best option. Alternative C, that is, deputation of engineering personnel from Construction India Limited to the vendors' works for expediting drawing approval and vendor data, was also accepted. But alternative B, which was tying up of certain percentages of payment to the defined milestones of data supplied by the vendor, was not accepted because of the reluctance on the part of the client for offering financial incentives.
The award of contract has been delayed owing to retendering of certain equipments because of modifications. This has resulted in late ordering and late erection of the equipment.
The soil data was generally assumed to be reliable based on previous soil investigations conducted in the project area. However, when detailed soil investigations were carried out for placement of heavy equipment, certain treacherous soil patches were found which called for extensive foundations.
In the initial stages of the project, locations of field boreholes, cone penetration tests and plate load tests were fixed based on the preliminary layout of the plant. This was done as it is impossible to carry out the detailed soil investigation to cover the entire project area due to the time and cost constraints.
The alternatives available were A. To have pile foundations for the major equipments. B. Split footings depending upon the location of the equipment. And C. To modify the equipment layout. Alternative C, that is to modify equipment layout, was felt undesirable. Alternative A, that is to have pile foundations for major equipments, and alternative B, to split footings depending upon the location of the equipments, were adopted.
Design of foundations for certain critical equipment such as tile columns, compressors, etc. need to be further checked by detailed study to ensure trouble-free operation of the plant. This led to conducting additional soil investigation tests at the locations of these critical loads and change in design and construction drawings at a very late stage.
During construction, extensive power cuts were resorted to by the State Electricity Board, from which construction supply was tapped.
Construction work was delayed since advanced planning for alternate source of electric supply was not done in advance.
The alternatives available were A. Purchase or hire a diesel generator set. B. Ask contractor to make his own arrangements and compensate for the extra expenditure. And C. Alternative sources for power of construction should have been thought out in the beginning and arrangements made for tapping of any available power in the area. Alternatives A, that is, to hire or purchase diesel generator sets, and B, to ask contractors to make their own arrangements and defund their expenditure to this count were found acceptable.
The construction work was delayed since it took some time to procure the alternate source of supply.
During the implementation of the project, the client had made several scope changes. These involved additional buildings to be constructed, extra tankage to be provided, etc.
At this stage of 90 to 95% completion time, the client came up with a major change in scope, both in the form of putting up additional number of tankages, which includes a large floating roof tank, as well as non-plant and plant buildings. Though we have a contingency plan to carry out similar work in change in scope within the time frame of the project, but at this late hour when the project was at the fag end of completion, such major changes have resulted delay.
The alternatives were A, indicate to the client the impact of the change orders due to scope changes with details of time and cost. B, convince the client not to bring in the scope changes or carry them out after project commissioning. Alternative A, that is, to indicate to the client the impact of change orders due to scope changes with details of time and cost, was followed.
This additional change in scope of work by having 2 more tanks as well as the plant and non-plant building at the fag end of the project had to be resorted to a contingency plan. As you know, all the works to be done additionally will require detail engineering work, procurement, buying of the equipment and material, as well as the construction work. Howsoever, we plan it and dovetail it into the project schedule, where having a tremendous impact on the overall completion time. And there was a delay which could not have been avoided by resorting to even contingency plan.
Piping bulk material takeoff, especially the third material takeoff and post-third material takeoff stage, had undergone a serious change because of process changes and non-completion of 80% isometric drawings at the third material takeoff stage. This resulted in new sizes creeping into the material takeoff, which necessitated fresh procurement action.
The third material takeoff for piping bulk materials and the subsequent identified items were ordered at quite a late stage, and the manufacturing of these, inspection of these, dispatch to site were quite delayed, and the arrival at site and their fitment did delay the project completion to quite some extent.
The alternatives available were A, avoid changes in the process package at such a late stage. B, wait for 80% isometrics completion before going in for third material takeoff. This may, however, result in further extension of the mechanical completion date. C, substitute piping materials to the maximum possible extent without looking at the optimum piping design criteria and replacing the odd sizing materials at the first shutdown of the plant. D, carry out all the changes and procure fresh material in crash procurement basis. The alternative D, that is, to carry out all the changes and order the fresh material on crash procurement basis, was followed.
The piping items that were identified at the third material takeoff stage and subsequently were ordered quite late, and the receipt of these items at site delayed the mechanical completion of the project.
The case study problems which you have gone through are just a few of the typical examples encountered during the project implementation. In a large project, the problems of the nature discussed here occur too frequently. In the life cycle of a major project, decision-making situations like the ones you reviewed here may take place on more than 100 occasions. You must realize the essence is one of the least cost options that is workable. When I mention of least cost, it is the total least cost taking both direct and indirect costs into consideration.